All right, so we didn't get through as much as we wanted yesterday, so I'm going to start today with worksheet 8B, which is arc lengths, okay? And then we're going to go on and talk about area of sectors, and then we're going to do both linear and angular velocities, okay? In my mind, these two are just formulas you need to use, okay? They're on your sheet. These are formulas, but they require a little more finesse as far as understanding what it's asking for. All right. So does this look like the worksheet you have out? Okay. What is it again? Can somebody tell me? 8B? Is that right? Yeah. Okay, let me just put that on there. All right. It's very important that we understand what these are and what they mean. It says theta is a central angle, so that seems okay, right? Theta is an angle, okay? This is super important here. It has to be in radians. If it's not in radians, none of these formulas work. You have to change it to radians. And how do we change something that was in degrees into radians, guys? Yeah, we need the 180 degrees to cancel, and then it'll be left in radians, okay? So that's to convert from degrees. We'll just have to do that a lot. Okay, the formula here, okay, R is the radius, and S, and these are not defined on your formula sheet. You have to know what they are, okay? S is the arc length. The distance along the arc. It's a piece of the circumference. Does that sound familiar? Okay. And the formula when you're in radians is just S equals R times theta. We had a formula in geometry for arc length, but we literally used degrees and circumference to find it. Everybody got that? We're just going to do two practices here. Number one says find the length of the intercepted arc, so we're looking for S, given the angle measure, theta, and the radius, R. Find your answer in terms of pi, so leave it exact and rounded to the nearest tenth. So if theta is 5 pi over 6, do we need to convert? No label on this, so it's already in radians. Everybody good? And then it says R is 3 feet. The formula is S equals R times theta. So we do 3 feet times 5 pi over 6. They want an answer in terms of pi, which means we don't type the pi in. So it's 3 times 5, 6. Is that what it was, guys? Did I remember the numbers right? And then you can do a math enter. But we get 5 halves because it was, this 3 reduces into the 6 twice. We end up with 5 halves pi. And that is a length of an arc. So what would the label be? What's the only label that was going on in this problem that we keep? Feet, right? Right, and then you're going to go back to your calculator because they also want it as in tenths, so you're going to say take that 5 halves and multiply it by pi. Or you can type 5 pi divided by 2. It should work either way. Anybody getting 7.9? Okay. So it's approximately 7.9 feet. Now we're going to do some area today, which is square units, but this is just a length. Okay, literally what this is saying, if you measured around 5 pi over 6, which is about this far, with a radius of 3 feet, the arc length would be the distance from here to here.
I thought I had one for you. I saw your name. No, I don't have it. All right.
Okay, sorry. Come back anytime. I'm going to skip down to number 5. What's different is that it is given in degrees. So this time theta is 15 degrees, but I can't have degrees. So I'm going to multiply by pi over 180 to change the degrees into radians. I'm not going to bother to reduce that because I'm just going to plug it into a formula anyway. You can if you want, but I'm not. And R was 8.4 meters. So S equals R times theta, or 8.4 times 15 pi over 180. Now I'm going to type in my calculator. The first time I'm not going to type the pi in. I don't know if this is going to come out nice at all. 8.4 times 15 over 180, is that correct? Oh, it did. Math, enter, enter is 7/10. Yes? And there was a pi, which would go in the numerator, so it's 7/10 pi. And that is, what was our label for our distance here? Meters. We did 8.4 times 15 divided by 180. Did that work? Okay, and then now we need to multiply by pi. I'm just going to type that last answer times pi this time. 2.2, anybody? So 2.2 meters. Okay, I'm not going to do 50 million examples. It's a pretty straightforward formula. We good? Look back at your notes if you don't remember later. I think those questions are in Delta Math, okay? To finish up yesterday. I do have one application problem that's kind of fun. It's at the top of the next page. Okay, Hofbauer's definition of fun is probably different than yours, but if we were talking about the Earth, Cincinnati, Ohio, on the surface of the Earth, has a latitude of 39.1, and Atlanta, south of it, has a latitude of 33.7. These are actually degrees, but let me show you what they really are saying. So from the equator, you went up 33.7 to get to this one, and you went up 39.1 to get to that one. Should have drawn it like that. Okay. If the Earth has a radius of 3960 miles, how far apart are these two cities? Okay, so can we figure out the angle in between those two cities, guys? If one's 33.7 north of the equator and the other one is 39.1 north of the equator, how would we find the angle in between them here? Yep, subtract. So can someone do that for me? 5.4? Yes? Okay. It's degrees though, so what do we have to do to it to make it our theta? Yeah, so our theta is going to be 5.4 times pi over 180. So S equals R times theta would be 3960, and remember that was in miles, times theta, which is 5.4 pi over 180. Let's just go straight to the decimal for this, because it's our application problem. It means nothing to me if you just give me in terms of pi. 3960 times, somebody yell if I get the numbers wrong, 5.4 pi over 180. 373 roughly. I'm just going to round to a whole number for this one. 373 miles. The reason I'm not being super accurate is, do you think the radius of the Earth is exactly 3960? I'm thinking that's an approximation too, okay? Did someone get that? Everybody get that number? All right, so that's an arc length question that's kind of interesting. We're going to move on to areas of a sector. This formula should be on your... Is it working, Adriella? No? Okay, This formula should be on your reference sheet. Somebody double check in for me that it's on the reference sheet. It's the only one that has an A. It's the area of a sector. Okay. There is a formula for area of a sector that you used in geometry, but that was in degrees, and it had to do with area of a circle, which this one kind of does too, but this one doesn't have a pi anywhere in it because it's part of theta. All right, so area is 1/2 r squared theta. I always remember it that way. I guess they have 1/2 theta r squared, but when I write it down, I'll probably write 1/2 r squared theta. Everybody okay? It does have to be in radians to use this formula. So let's look at number 12. Uh-oh, what's wrong right away on number 12? It's in degrees. So our theta needs to be 74 times pi over 180. Again, I'm not going to bother to do anything else with it because I'm going to type it in my calculator anyway. Yes. Go to mode. And I think there's somewhere in there that you can just put it in English. Did you find it? Scroll down. It's the last one, maybe they said. Okay, R was 4 centimeters. And the formula again for A is 1/2 r squared theta is the way I usually write it. So do you want me to use a fraction or a decimal for 1/2? Anybody have a preference? Probably faster to type 0.5 in your calculator, huh? 0.5 for the 1/2. For the r squared, we're going to have 4 centimeters squared. You could just type 16 or 4 squared. And then you're going to multiply by theta, and our theta was messy, but we're just going to put the whole thing in without reducing it. So we have 0.5 times 4 squared times, was it 74? I already forgot. 74, oops, pi over 180. I didn't say what to do exact, so I'm just going to do it as a decimal. Did anybody else get 10.3? Okay. This is area, and these were centimeters, but what did we do to those centimeters right there? We squared them, yes? And area is always square units, so this should be 10.3 square centimeters. Is everybody okay with that? Because it's not a distance, it's an area. It's the filled in part of the sector there. All right, let's do one more. Let's do this number 15. This time it's a big chunk of the circle, but it doesn't matter. They give us the angle either way, but the angle is in radians already, right? That's a plus. So we have 1/2 r squared theta. Thanks. So we're going to do A equals 0.5. R is 23.6. Maybe I'll put the little meters there this time to remind us. We're squaring it. And then it's times theta, which is 19 pi over 12. Literally just typing question. All right, was it 23 point? Thank you. And that was the radius. You got to remember to square it. Times 19 pi over 12. Thank you. Okay, type carefully. That's a lot to put in, but I got 1385. Anybody else? Okay, 1385.2 meters squared. Okay, so as long as you have the reference sheets, do you think you can do those kind both? They're just following a formula. Okay, those aren't too tricky. Then we are going to move to 8.5. I forgot this whole part of the packet originally when I had all the pages numbered, so I stuck these in with random numbers, 8.5, 8.6. Sorry, I didn't want to renumber the whole packet. All right, honestly, I don't even, it says arc length can be used to analyze circular motion. Suppose an object moves along a circular path with a radius of r. That rate at which the object moves along the path is called linear speed. So it's how fast this goes to here, goes to here, goes to here, goes to here. Okay? I don't even think of this formula. It is on your sheet. I always just think that linear speed is v, and it has to be distance over time. Okay? It's distance over time. So when they give me, you can write all that down if you want. It's v equals distance over time. So it might be feet per second, or miles per hour, or it might be centimeters per minute. But I know I got to take the distance and divide by the time, okay? The second one is an angular velocity, and they use the Greek letter omega. This just looks like a W to me, but we can just say W if that feels better. Is always radians per time, okay? They give you a formula here. They say they take the angle and divide it by time, but it's got it, as long as you are in radians per time, like radians per second or radians per minute, you found an angular velocity. What it is not is revolutions per time. If they give you revolutions, you have to convert it to radians, okay? And what do we know? Revolutions would need to be converted by what? Anybody know? One revolution is 2 pi radians. This is the conversion that you're going to have to use whenever they give us revolutions. You're going to have to say, well, I got to get rid of the revolutions and change them into radians, so I'm going to have to multiply by 2 pi. Does everybody see what will happen then? The revolutions cancel, and it'll change to radians. Let me move that. I didn't realize it was better. Sorry about that. Everybody got what they want off that slide? All right. Oh, I didn't talk about what it really means, though. Angular speed. Okay. So if you were a DJ, spinning records, right? Linear speed is when the fly lands on the edge of the record, it's how fast he's going around in miles per hour or centimeters per second or whatever. The angle is if you took this radius, that's how fast the angle is changing here. It's in radians per time, okay? It is the angle, like how fast did it go from here to here, that angle, okay? The distance out here is the linear speed. It's confusing. We always talk about linear speed. We don't ever think about angular speed. All right. This is actually on the next page, but this is the formula that I use all the time. I don't use all these other formulas in between, and you don't even have to write them down if you don't want to. The one I use all the time is to find the linear speed, you take the radius times the angular speed, okay? You can use the angular speed to find the linear speed. You just multiply by the radius. So rather than teach you 16 different formulas, that's the one I'm going to use. If you want to circle it on your reference sheet, I'll let you, okay? You find the V equals RW1. Okay, it's about the only one I use on there besides the S equals R theta and A equals 1/2 R squared theta. All right, so here we go. It says a bicycle tire has a radius of 14 inches. So this is back on the previous page. Our R is 14 inches. And it is rotating at a rate of 125 revolutions per minute, RPMs. I am going to find the angular speed first so that I can use the angular speed times the radius here. I guess I wrote that backwards, but it's the same thing. It's theta R or WR. Yeah. All right. So we're going to use that to find the linear speed, which means we need to already know the angular speed. Okay, the angular speed, just what did I tell you a minute ago about angular speed? It has to be what? Radians over time. So we have to do radians over time. What do we know? Well, from right here, we knew 125 revolutions per minute. We already have over time, don't we? The only thing that's wrong is it's not in radians. Well, our dimensional analysis says revolutions need to go in the bottom so that they cancel. Yes? What do you know about a revolution? All the way around is how many radians? 2 pi radians is equal to 1 revolution. So now the revolutions divide out. We have 125 times 2. Can you do that in your head? 250. And there's a pi. Don't ever lose that. And that's radians. And we have minutes in the denominator. Is that radians per time? It's all we needed. I don't ever use those formulas. I just look at the labels. Does that make sense? I need radians per time. You can use a formula. All right, and then over here, what does it say? To find the linear speed, all we have to do is take that answer, 250 pi radians per minute, and multiply it by R. What was R, guys? 14 inches. Now, for you science people who are really good with the dimensional analysis in the area, math has this magic issue called radians. Remember how you don't usually write the word radians when it's in radians? That's because that label can just magically go away because these formulas are assumed to be in radians. So if this label goes away, what is left for our labels? Inches and minutes. Everybody good? So we are going to have inches per minute because radians goes away. All we have to do is take 250 pi times 14. It doesn't say, I would just as soon you do everything in tenths because it will make more sense because in terms of pi doesn't mean anything to us. 250 pi times 14. I got, maybe we'll round that to a whole number, 10,996. Would that be okay? You can put 995 point whatever. It's just that it's so fast. Now, on a quiz or test, that might ask you to convert to feet, and we'll do some like that. But it just said here inches per minute, and that's what we wound up with. And I don't care if you put 1099, 5 point, whatever it was. Did I write it down right, guys? 10995.6. I just rounded it. Too many places. All right. I'm going to skip down to number 5. This is very, very similar. It's just going to require some extra steps. First of all, 16 inches in diameter. What do we need for our formula, or for any of our formulas? The radius. Is everybody good with that? Diameter is all the way across. So the radius would be 8. Is everybody okay? Remember that vocabulary? Okay, and it is turning 500 revolutions per minute. Okay, that is almost an angular speed. If we can make it an angular speed, we'll be almost done. What do we have to do to make it radians per time? Yep, multiply by 2 pi radians is equal to 1 revolution. So the revolutions cancel. So 500 times 2, guys? 1,000 pi radians per minute. Okay. Rather than use 5,000 formulas now, we're back to the same one, right? We know a radius and we know an omega or W thing. So the formula is V equals, does your sheet have W times R? Is that what you said? Okay. So 1,000 pi radians, whoa. I'm not even going to bother with the label because it's going to go away. Radian per minute. That's our omega, times our radius is 8 inches. Now, before I start calculating, some evil person wrote this worksheet. It wasn't me, but it could be on a quiz that you have to do this, and that would be my fault. What do they want? Miles per hour. I don't think I went this far on the quiz, but we need to do some converting. We don't want inches and we don't want minutes. Hopefully you remember some dimensional analysis. Okay, let's do the easy one. Minutes we need to become what? Hours. Where do we want to write minutes then? So that it will cancel. We want to write minutes on top so that it will cancel. And then you need to figure out what is it you know about minutes and hours. 60 minutes is an hour, so the 60 goes with the minutes, and it is equivalent to 1 hour. So now the minutes will go away. Are we in hours at least now? Something per hour? All right, the rest of this, I'm not sure that, I hope you know the first one, but I'm not sure y'all know the second one. Okay, we need to get rid of inches, and I can write that as inches if it's better for some of you who don't know those little marks. I need inches to go away, so I'm going to put inches on the bottom. Does that seem okay? And then what do you know about inches? 12 inches is 1 foot. Do you know that one at least, guys? Okay, so 12 inches goes in the denominator and 1 foot goes in the numerator. Now the inches will cancel and we're into feet. I think I have like feet per minute on the quiz or something. It's not anything too complicated. But they asked for miles. Does anybody know the conversion for miles from feet? 1 mile almost 5,280. Okay, why did I put that number on the bottom again? So I needed the feet to cancel out here. Feet, feet. Okay, this one is very tricky for students to type in because if you do it wrong on the calculator, it won't put the right things in the denominator. So what I would like you to do is just do the top and the bottom separate, and then we'll divide them. So can you type 1,000, go ahead and type the pi in, times 8 times 60. 1,000 pi times 8 times 60. It's a very big number, right? Sure.
I'm just gonna say it's 1,796.45.
Okay, we won't be worrying that far out. All right, and what do we have in the denominator? It's a 1 times a 1 times a 12 times a 50 to 80. Which is like that. Okay, now what do we have left to do? Just divide those. And I didn't have room for my labels here, but the only labels left were miles on the top and hours on the bottom. So what did you get when you divided? Anybody? A little louder. 23 point. Okay, like I said, I don't think I did all the way to miles on the quiz because I was worried you wouldn't know that 5280 number. If you ever do need it on a quiz, I would put it next to the question, okay? Or put it on the board or something.
So is that label miles per hour the same as if you just wrote like?
Yeah, you can write MPH. Yep, good question. You can write MPH for miles per hour. I don't care. All right, that was a complicated mess. Let's see if we can try number 6. Oh, this is easier. I promise. It wants just an angular speed in radians per second. Guess what? You don't need to know the diameter. All you need to know is it's 2,800 revolutions. Oh, we do have to do some converting though. I guess we have 2 things to convert. What 2 things? Somebody tell me what we need to change. Okay, so 1 revolution is 2 pi radians. So that makes revolutions go away. Now it is actually an angular speed, but it's not in seconds yet. So is it okay if we do it all at once here? What do we need to put minutes so that it will cancel? And we're looking for seconds. What do you know about minutes and seconds? 1 minute, so that goes with the minutes up here, is 60 seconds. So we're going to end up doing what? Dividing because it's in the denominator. This time I think we're okay to do it in the calculator because there's really only one thing in the denominator, right? All right, so this time we have 2,800 times 2 pi divided by 60 because that's, when there's more than one thing in the denominator, you either have to use a bunch of parentheses or you have to do it separately. And I already forgot. You guys are just going to have to type it and tell me what you came up with. Yes? No? Did that include the pi? Everybody good? Usually someone forgets to type the pi in on the quiz. That's a very common thing. And then they don't write the pi either. They just forget it altogether. All right, we ended up with radians per second, and we're done. Yay. Yes. You could assume it goes away, but it's per second, so don't put the seconds on the top. Do you know what I'm saying? Make sure it's, if it's just over seconds, yeah, you. All right, we're gonna go to number 8. Try one more of these linear speed questions. I think this is the last one. Am I okay on time? All right. Last question here. A ceiling fan with blades. Okay, so this is not a ceiling fan blade, but does that kind of really badly look like what we're talking about? So if the blades are each 25 inches, what is that in regards to this? The length of this blade is the radius. Does that make sense? If the blade is 25 inches, that's the radius. You don't have to draw a picture if you don't want. Just write the radius is 25 inches. But does it kind of make sense? I assume they're talking about the little one paddle of the blade, not like from one end to the other. So we're going to go with that. All right. And it is rotating. What does this mean? RPMs. Yeah, it does mean revolutions. It doesn't mean radians, okay? So we have 40 revolutions per minute. I'm going to write it that way because I want to change it into an angular velocity. Anybody know what we can do to change it into an angular velocity? Only have one step. It's got to be in radians, right? So 1 revolution is 2 pi radians. So the angular speed that I have right now is 80 pi radians per minute. Is that okay? 40 times 2 is 80. You could type it in the calculator, but I'm just going to leave it 80 pi radians per minute. I didn't have time or space to write radians in there, but okay. What's the relationship between radius and angular velocity to get linear velocity? It's V equals, does it have, is it omega r? I keep forgetting which order your sheet has it. Okay. So we have 80 pi radians per minute. And I'll go ahead and put right next to it, they're going to multiply by 25 inches as our R. Now, we could go ahead and do that part, but I think we got some converting to do before we're done. They want us in what? Feet per second. Ooh, this is one I could put on a quiz because I hope you know inches to feet, and I hope you know minutes to seconds, right? All right. I don't have a lot of room here. Can I squeeze in those two conversions? Since I drew a ridiculously large fan blade over there. Where does minutes need to go? On the top, which leaves seconds on the bottom. Okay. What I know is that it takes 60 seconds, so the 60 goes down with the seconds, to be 1 minute. Now the minutes can cancel, and I have seconds, which is what they wanted. But they also wanted feet, so I need inches to cancel, so inches is going to go in the denominator. And what I know about inches is that 12 inches, so the 12 goes with the inches, is 1 foot. Now the inches label cancels, the radians label magically disappears, and I have left feet and seconds. Okay, again, there's two things in the denominator. Do you want me to show how you could do it all at once, guys? You could type 80 pi times 25, but then you have to divide by both 60 and 12 multiplied together, or you could go ahead and do 80 pi times 25 times, and you would need parentheses, 1 over 60 times 1 over 12. Does either one of those make more sense to you? Or you could just do the whole top and the whole bottom. Okay. If you did 80 pi times 25, I don't know what that is, do I? 88 quarters is, I think it's 2,000 pi. And then the denominator would have 60 times 12, which would be 720. But I'm just doing it in my head, so that could be wrong. $8.7, anybody? Whichever one of those many ways you did it. This was times, that looks weird. Just because both of those are in the denominator, okay, you're dividing by both of them. Otherwise, this way seems to make sense, maybe to some of you. 1 over 60 and 1 over 12. Either way, you should get 8.7 feet per second. Did everybody type it one way or the other, please, so you know you're getting it? All right. Yes.
I got 1256.6.
Can I
You
see your,
put parentheses around the 60? No, 12. 'cause
you
that's
did
what
or didn't put parentheses? 60 times 12 in the parentheses? Can I,
that's what
can I see it?
got when I did.
Okay, guys, can you turn to the next page and I'll just have you circle some problems so you know what the homework is? Oh, it's gotta be all in one parenthesis because what your calculator's doing is 60, it's multiplying and then it's dividing by 60 and then it's going back to multiplying.
Oh, okay.
The 60 times 20,
Okay,
or
so-
60 times 12 need to be in one parenthesis.
Okay,
This,
so then it, okay,
this probably makes the most sense right here
let me,
for a lot of you. All right, guys, these are the ones you need to circle. Are you on 8.6B right now? Is that where you went? Okay, circle 1 and 2, 6 and 7, and then 10 and 11. 1, 2, 6, 7, 10, and 11. And then go back to 8.5A, that was the arc length and area of a sector ones, and just circle 13, 14, and 17. These are arc length, no, area of a sector, actually. Arc length is in Delta Math, but none of this other stuff is in Delta Math, so I have to assign it on a worksheet, okay? Delta Math is based out of New York, and apparently New York standards don't include